Okay, good afternoon everybody. Today we are going to learn about double slit interference. As we know that interference is a mix or a joint of two sources of light which have same frequency. Okay? So the light comes and then enter the slit. Okay? So we have two slits here, or double slit. And then this is the light comes through the slit. So this light beam comes through the slit, and then there will be pattern that is formed in the screen that can be observed. Okay, the pattern is dark and bright. Okay, the center of the bright here, that we see here, if we put the line like this, there will be pattern here that we see the center of bright or maximum. Okay, so then there will be also dark pattern in here. We see dark one, and then this one also dark one. Okay, this is dark, this is bright, this one is dark, and there will be also bright one, and there will be also bright one. So if there is one dark below, there will be one dark above. If there is one bright or two bright below, there will be two bright up, okay, or above. So if we put the notation here, just like L, which is the distance between the grains or the slit to the screen, which is L, and then the distance between the slit is D, and also the distance between the dark one, so let's say this one is the dark one to the center is Y. So we are going to observe the equations of the double slit interference for the bright pattern. Okay? So if we are drawing here, if we draw the lines from this point, okay, from this slit to the bright one. Okay, so sorry for this one for Y, yeah, the distance from the bright one to the center, which is Y. So if we draw here from this point to the bright one, okay, like this, and then also we draw the line here from the second slit, and we draw the line that is perpendicular to the first one. Okay, so if you note that this line is, let's say, S2, and this line, let's say, S1, so there will be the difference pass between S2 and S1, which is delta S. So the delta S is in here. This is the distance. The distance is called delta S, and this one is perpendicular. And if we put the angle between them is theta, so the theta itself, so the sine theta is equal to delta S divided by D. So we can say that delta S is equal to D times sine theta. Okay? And the next is, if we can see here that for the bright pattern, we can see that delta S is equal to M times lambda, which M is equal to 0, 1, 2, 3, etc. Okay? M is 0 for the center of bright maximum, or maximum to the bright one. M is 1 is for the bright one, M is 2 for bright 2. Okay? So we can say that delta S is equal to M times lambda is equal to D sine theta. If we can see here that theta here is very small, so that we can say that sine theta is equal to tangent theta. Okay, so if we can see here that if we take one line from this point to this point, okay, so we can get this triangle perpendicular. We can see that theta, or the angle in here, will be the same with the angle in here, so that we can conclude that the tangent theta is also equal to y over L. Y over L. Okay, so we can see that m times lambda is also equal to d times y over L. This is the equations for bright pattern. Okay, what about the dark pattern or destructive interference? For the dark pattern, you can see that delta S is equal to m minus half times lambda, while m is started from 1, 2, 3, etc. Okay, so that we can see here that the formula of delta S is equal to m minus a half times lambda is also equal to d times y over L. So this is the equations for the dark pattern. Okay, or we can say destructive interference, and for this is constructive interference. Okay, may this video help us to understand about double slit interference. Okay, see you for the next video. Thank you for your attention.